Good day, friends. Today we will talk on the Grable-Deal estimator, combining estimates when variances are unknown. In class 11, 12, when we first studied statistics, our teacher told us that statistics is the science of making decisions in the face of uncertainty. In the face of uncertainty. So statistics is all about dealing with uncertainty, and Grable-Deal estimator is a concept based on how to deal with uncertainty. Combining estimates when variances are unknown. Larger the variance, more is the uncertainty, and less is the trust. So that is the base of Grable-Deal estimator. So we start with a case with two experiments, one common parameter they are measuring, and obviously there are two estimates. So we are measuring the same quantity theta. To unbiased estimate x1, x2, variances are unknown. Which estimate should we trust more? So is it a question of discarding some data, taking one of the estimate as a good estimate? Then you are losing half the information. So there are various ways to combine the two estimates. To start with, one can take the grand average x1 plus x2 by 2. But this assumes equal reliability, ignore variability, often inefficient. Real world data sources are rarely equal in variance. Okay, so there is variance, but you are ignoring the difference in the variance. Why simple averaging fails? So the key insight is more variability, less trust. Let the data decides weights. Use observed variability, which is known as adaptive combination. The idea leads to Grable-Deal estimator. Grable-Deal estimator is defined as a s2 square x1 plus s1 square x2 by s1 square plus s2 square, where x1 x2 are the estimates of theta, and s1 square and s2 squares are the sample variances. So of estimate 1 is to estimate 2. So larger variance, smaller the weight. Intuitions: think of two sensors, sensor A stable reading, sensor B noisy reading. Should we go for only stable readings? Then we are discarding half the data. So combine both the readings from both the sensors. Noisy source of data contribute less, stable source dominates. That is the idea of Grable-Deal estimator. No true variances are needed to be known. This was one of the topic of my PhD research, and we used to give the example that you are measuring the pollution index of a place. You have two samples. You have two groups of samples, and you send it to two different labs. One come up with quick and crude result. One come up with costly but more precise result. The Grable-Deal estimator tells us how to combine these two different estimates, as shown in the previous slide. Some statistical properties of the Grable-Deal estimator: unbiased estimator of theta. Grable-Deal estimate is unbiased. That can be mathematically proved. More efficient than sample mean. More efficient than the grad mean. That can be mathematically proved. Uses sample information only. All the weights and the estimations are based on the data provided by the sample. No no personal feelings is used, no personal belief is used. So the idea is practical, data driven, and elegant. Admissibility is one of the key features to set up the power of a test statistic, or power of any statistic. Neither Grable-Deal estimator is proven to be admissible. There exists no estimator that outperforms Grable-Deal estimator for all parameter values. There is no estimator that beats Grable-Deal estimators uniformly. That is not proved yet. Neither, no estimator is found that beats Gabriel estimator for all parameter values, but the converse is also not shown that there exists an estimator that beats Gabriel estimator. So this is an open problem. Admissibility of Gabriel estimator is still an open problem, although ChatGPT tells me otherwise, that it is settled. But to my knowledge, this admissibility of Gabriel estimator is still an open problem. Although admissibility of Gabriel estimator is proved in some restricted setups, that is done. Some some fields where it is applied, where it appears: meta-analysis, sensor fusion, clinical trials, multi-source data integration, ensemble estimation. Any setting with multiple estimates, unknowns, uncertainty, we use the Gravel-Dill estimator or Gravel-Dill concept. The concept of Gravel-Dill estimator. Big takeaway: when uncertainty is unknown, let the data decide trust. The Gabriel estimator is not just a formula, it's a principle of adaptive estimation. Closing remark: good estimation is not choosing side. You don't discard data, you don't discard information. It is weighting evidence wisely. You put proper weights to proper data. Less the variance, more is the trust. Thank you. I shall stop here. Like, comment, share, subscribe my video. I am available for one-to-one discussions too. Thank you.